Every great product starts as an idea, a sketch, a vision for the future. But the hard reality is over 70% of those ideas die before they ever see a factory floor. The biggest reason isn't a lack of genius. It's building something that 42% of the time nobody actually wants. This mistake gets cemented early, right in the engineering and design phase, long before manufacturing. We'll now expose the hidden traps in the engineering stage and show you the framework to avoid them. Even for launched products, success is rare. It takes, on average, 7 to 9 ideas to produce just one winner. A primary cause of failure is massively underestimating the technical complexity hidden in the details. Teams aim for a masterpiece at once instead of a simple, testable version, and then run out of resources. Mistakes hide in plain sight. Wrong materials that fail under stress or tolerances too tight for mass production. Another classic trap is over-engineering, a complex solution that adds cost, failure points, and repair difficulty. So, have you honestly assessed your idea's complexity? Are you building an MVP or a feature-packed dream? To combat this, teams use a proof of concept, or POC. Its only job is to answer, is this technically possible? But a POC is not a product. A prototype comes next to validate the user experience. Does it solve their problem? A POC is a tangle of wires on a bench. Confusing it with a finished vehicle is a path to failure. Even a good prototype has blind spots. Insights you gain are often limited to the specific features being tested. What are you building now? A POC to prove a theory or a prototype for user testing? Know the difference. With a great prototype, a new chasm appears: manufacturing. What proves it can actually be built at scale? The bridge is built with CAD, but this is where tiny dimensional errors become catastrophic and costly failures. Too many startups rush this part. They skip early design validation, a direct path to rework and blown budgets. This process is called Design for Manufacturing, or DFM. It asks, can the factory make this efficiently? Skipping early DFM reviews can dramatically increase your final unit costs, a mistake that can bankrupt a company. Look at your design. How much thought have you given to the assembly line? Is it simple or a production nightmare? This leads to a surprising counterintuitive point. You want your prototypes to fail. A failure in the lab is cheap. So what proves a product can be built at scale? A mature prototype that has survived rigorous DFM analysis. But there are deeper issues. The performance of your prototype can shift drastically during mass production. One of the most insidious risks is tribal knowledge. If assembly depends on one person's head, you can't scale. Is your process documented and repeatable? Or are you relying on luck and individual heroes to succeed? Let's connect this. Remember the 42% of startups failing by building things no one wants? That's an engineering failure. Recall the cost penalty for skipping DFM? That's directly linked to the mistake of building the final product too soon. The journey from POC to prototype to DFM isn't a series of steps. It is a validation loop to kill bad ideas cheaply. That shocking 70% failure rate isn't a death sentence. It's a filter. This process is how you get through it. To avoid these mistakes, follow a 3-stage validation process. 1. Validate feasibility with a proof of concept. 2. Validate desirability with prototypes. Let them fail so you can learn, iterate, and improve the design. And 3. Validate manufacturability with DFM. Can it be built affordably at scale? Document everything. Your idea is too important to lose to a preventable error. Build smart, validate rigorously, and turn your vision into reality.